Hello everyone, and welcome to this video on architectural design patterns in Python. In software engineering, design patterns are reusable solutions to common problems that arise during software development. In this video, we'll be focusing on some of the most common design patterns used in building software systems using Python. Section 1, Creational Patterns. The first category of design patterns we'll be discussing are creational patterns. Creational patterns are used to create objects in a system. Some of the most common creational patterns include singleton pattern. The singleton pattern ensures that a class has only one instance, and provides a global point of access to it. This pattern is commonly used for system-wide configuration or logging. Factory pattern. This pattern is used to create objects of a specific type without specifying the exact class of object that will be created. This pattern is useful when you have multiple implementations of a specific interface and want to create objects without having to know the implementation details. Builder pattern. The builder pattern separates the construction of an object from its representation, allowing you to create complex objects step by step. This pattern is useful when you need to create objects with many parameters that have default or optional values. Section 2, Structural Patterns. The second category of design patterns we'll be discussing are structural patterns. Structural patterns are used to organize code in a system. Some of the most common structural patterns include adapter pattern. This pattern allows you to adapt an existing interface to a new interface, without having to modify the existing code. This pattern is useful when you have an existing interface that you want to use in a new context, but the new context requires a different interface. Decorator pattern. The decorator pattern allows you to add new behavior to an object dynamically, without having to modify the existing code. This pattern is useful when you want to add new features to an object without having to create a new subclass. Facade pattern. The facade pattern provides a simple interface to a complex system, hiding the implementation details from the client. This pattern is useful when you want to simplify the interface to a complex system and make it easier to use. Section 3, Behavioral Patterns. The third category of design patterns we'll be discussing are behavioral patterns. Behavioral patterns are used to manage the interactions between objects in a system. Some of the most common behavioral patterns include observer pattern. The observer pattern allows you to notify multiple objects when a specific event occurs. This pattern is useful when you have a set of objects that need to be notified when a specific event occurs. Command pattern. The command pattern encapsulates a request as an object, allowing you to parameterize clients with different requests, queue or log requests, and support undoable operations. This pattern is useful when you want to separate the object that issues a request from the objects that execute it. Template method pattern. The template method pattern defines the skeleton of an algorithm in a superclass, allowing you to define the concrete steps of an algorithm in subclasses. This pattern is useful when you want to define a common algorithm structure that can be customized in specific ways by subclasses. Section 4, Model View Pattern. The model view pattern is used to separate the representation of data from its underlying data model. This pattern consists of three main components: the model, which represents the underlying data, the view, which displays the data to the user, and the controller, which handles user input and updates the model and view accordingly. Model. The model component represents the underlying data and provides methods for accessing and manipulating the data. In a Python implementation, this could be a class that encapsulates the data and provides methods for querying and updating it. View. The view component displays the data to the user and provides a way for the user to interact with it. In a Python implementation, this could be a graphical user interface, GUI, or a web interface that displays the data and provides buttons or other controls for the user to manipulate it. Controller. The controller component handles user input and updates the model and view accordingly. In a Python implementation, this could be a class that listens for user input events and calls methods on the model and view to update them. The model view pattern is useful for separating concerns in a system and making it easier to manage and maintain. By separating the data model from its representation, you can make changes to one component without affecting the others. This makes it easier to add new features or modify existing ones without having to rewrite large portions of the code. And that's it. We've covered some of the most common architectural design patterns used in Python. Remember, design patterns are not silver bullets, and should be used judiciously. Use them when they make sense for your specific use case, and don't use them when they don't. Thanks for watching, and see you next time.